Hello, welcome to The Extraordinaire, where we are committed to the relentless pursuit of excellence. If you love tech, you want to skill up, or you just like learning new things, subscribe to the channel so that you don't miss any of our content. Today we are going to be looking at reading and writing files in Python. The way that we read and write files in Python is with the open function. The open function returns a file object and is most commonly used with two positional arguments and one keyword argument. So let's see an example of that. Example 1.py. Here we say f is equal to, f is the file object, is equal to open. Our file name is work file, comma w, which is the mode, and then encoding is equal to utf-8. Now let's run this. If we do that, Python 3 example 1 and run, we see that it creates a new empty file in our directory here. The first argument is a string containing the file name. The second argument is another string containing a few characters describing the way in which the file will be used. Mode can be R when the file will only be read, W for only writing. An existing file with the same name will be erased, and A opens the file for appending. Any data written to the file is automatically added to the end. R plus opens the file for both reading and writing. The mode argument is optional. R will be assumed if it is omitted. What we've just seen here is that we have a couple of options for the value of mode. So mode can either be R, which is equal to read only, as read only. Then it can be W, which is write only, is write only. It can be, and when this is write only, if you have an existing file with the same name, with when you put the mode as write only, it would overwrite that file. So what that means is that if there's content in the existing file, that would be overwritten and we would lose that content. So you have to be very careful when you use this mode. Just overwrites existing files. We have mode equal to R plus, which is equal to read and write. And then finally we have append, which is just appends to the end of the file. So those are the different values that can be passed in as the argument for the mode. Normally, files are open in text mode. That means you read and write strings from and to the file, which are encoded in a specific encoding. If encoding is not specified, the default is platform dependent. Because UTF-8 is the modern de facto standard, encoding equal UTF-8 is recommended unless you know that you need to use a different encoding. Appending a B to the mode opens the file in binary mode. Binary mode data is read and written in byte objects. You cannot specify encoding when opening file in binary mode. That's very self-explanatory. Basically, UTF-8 is the de facto standard and we don't need to change it unless we need something very different. Also, we can append B to any of these modes. So if we add B here, it means that we are opening this file in binary mode to read only. Same thing here, if we add B here, we're opening this file in binary mode to write, and if we add B here, it's read and write, but it's in binary mode, and here as well. So appending B like this in front of the mode tells it that we are opening the file in binary mode. In text mode, the default when reading is to convert platform specific line endings as /n on Unix and /n and /r and /n on Windows to just /n. When writing in text mode, the default is to convert occurrences of /n back to the platform specific line endings. This behind the scenes modification to file data is fine for text files, but will corrupt binary data like JPEG or EXE files. Be careful to use binary mode when reading and writing such files. It is good practice to use the with keyword when dealing with file objects. The advantage is that the file is properly closed after its suite finishes, even if an exception is raised at some point. Using with is also much shorter than writing equivalent try finally blocks. So what this is saying is we can use with open work file to create a file encoding to either for reading and writing. Encoding is UTF-8 as F. Then we can say read data equal to F read, and as it. Now the advantage of using this with keyword is that when we use it, we don't have to manually close the file object. It is closed automatically for us. So we could see an example of using this with keyword by, first of all, let's comment it. Let's comment this part, and I'll create a new file here. Let's just say workfile.txt. Let me run this again. Example 1. Yeah, create new workfile.txt, and then inside workfile.txt I'm going to say the quick brown fox jumps over the lazy dog. And now I'll comment this one out and uncomment this, and I'll open this one. Remember, if we don't pass the mode, it is set to R, which is read only by default. So just set workfile.txt here. We read the file, then we're going to print out the value. So read data, print that out, and what do we have? Very nice. We can also check to see that a file has been closed. So I'll comment this one out. Let's leave it in, and we'll just do print f.closed. This would return true or false depending on whether the file object has actually been closed. So let's run this again, and we get true here, which means that this file object has been closed. If you are not using the with keyword, then you should add the close method to close the file and immediately free up any system resources used by it. Basically, if we are not going to use with, then we have to use the close method on the object to close the file. So I'll take that off now. Calling fwrite without the with keyword or calling the close method might result in the argument of fwrite not being completely written to disk, even if the program exits successfully. So that's something that we should be aware of. If we call this, if we open a file and we don't close it, it may end up not saving the contents of the file if we are writing to that file. So that's is very important that we take note of that, which is why it's also very important that we just adopt using with by default. After a file object is closed, either by a with statement or by calling the close method, attempts to use the file object will automatically fail. Let's see an example of that. If we try to say f.read here again, what do we get? We get an error. So now we're going to look at some of the methods that Python provides for us to manipulate files. To do that, we're going to create another example file here. So say example2.py. To read a file's contents, we call the read method on the file object, which reads some quantity of data and returns it as a string in text mode or byte object in binary mode. The size is an optional numeric argument. When size is omitted or negative, the entire contents of the file will be read and returned. It's your problem if the file is twice as large as your machine's memory. Otherwise, at most, the size characters in text or size bytes in binary mode are read and returned. If the end of the file has been reached, the read method will return an empty string. So let's see, for example, we open up the file here. So open workfile.txt, and we're opening it for reading, so we don't need to set the mode, but we say the encoding is etf8. Now we can print and now we can read the content of the file and print it to screen. I'll change this to example 2, and that works fine. Very good. If we try to read again, we should get an empty string. f.read. Yeah, just empty. The readLine method reads a single line from the file. A new line character \n is left at the end of the string and is only omitted on the last line of the file if the file doesn't end in a new line. This makes the return value unambiguous. If the readLine method returns an empty string, the end of the file has been reached, while a blank line is represented by \n, a string containing a single new line. So let's add some more lines to this work file. So we say Mary has a little lamb. We have ring around the rosy. And then we have Old McDonald's as a fan. We are going to read the lines from this file. So we have, how many lines do we have? Four lines. So we're going to read and print as we go. So we say print as the line is equal to f.readLine. And I will print line. Now I want to show us something. If we just print this line, we'll notice that it just prints a single line and then gives us a space, and that's because there's actually a new line added at the end of this string, but that is being formatted, or that's being interpreted by the interpreter. So in order for us to see that new line, we're going to have to change this using the REPR function. Now if we run this, hold on, yes, we get to see the string together with the the new line character. Now let's repeat this 3 more times. So this is 1 2 3 1 2 3 4 5. No, just 4. So 1 1 2 3 4. Yeah, we still need the 5th one so that we can see the empty line. And if we run this now, so we get this. Each of the lines has a new line character. The last line doesn't have a new line character, and then the very end we have an empty string. So reading lines from a file, you can loop over the file object. This is memory efficient, fast, and leads to simple code. So instead of doing all of these, we can just take one of these guys here and say for line in F, print line end equal to empty. And now if we run this, we get each of the lines, and notice that in this case we no longer have them on a separate line. Why? Because we are now, the end line is now an empty string. It's just an empty string at the end here, so it doesn't take the item to the next line. We don't have that new line character at the end of each string. If we want to read all the lines of a file in a list, we can use the list function by passing the file object, or we can use the read lines method on the file object. So let's see that example. So the first example is using, we'll say print list F list F, and if we run this, we get the file, the lists. Also, we can do f.readlines, which if we do this, we get each line as a list, which is here. These are the methods for reading a file. Now, what if we want to write to a file? Let's create a new example file here. Example 3.5. So if we want to write to a file, we can use the write method on the file object, which writes the content of the string to a file. So as an example, we're going to open this file for writing. We're going to open a new file for writing. So we say with open new file.txt w including equal to utf-8 as f. Then here we see f.write this is a test /n. Now, in order for us to see the characters, we're going to wrap this in a print function. And now if we run this example, you see that we get 15 characters, and the new file has been created. This is a test which contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 characters. Why? Because there is a new line character as well. So that gives us a total of 15 characters. Other types of objects need to be converted either to string in text mode or to bytes in binary mode before writing them. And as an example, first we are going to change this to append, and then we are going to comment this one. Now we will write another one. Here we are going to say value is equal to the answer, comma 42, and we convert this to a string by passing it through the str function. Then we can now write it to the file. If we run this, but to see the number of characters, we need to print this. Now let's run it. We get 18 characters, and we also get the values in the file. The tail method returns an integer giving the file object's current position in the file, represented as number of bytes from the beginning of the file when in binary mode, and an opaque number when in text mode. To change the file object's position, use the seek method. The position is computed from adding offset to a reference point. The reference point is selected by the whence argument. The whence value of 0 measures from the beginning of the file. 1 uses the current position, and 2 uses the end of the file as the reference point. Whence can be omitted and defaults to 0, using the beginning of the file as a reference point. So here we can open the file as, let's comment this out. Let's copy, then we comment it out. We can open this file as a, you know what, let's just create a new example file. So I'll create a new file here. New file, say example 4.5. And inside here, I'm going to open f equal to open work file. We're opening it for read and write, and we're going to write f.write e 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, E, C, D, E, F. And if you run this, example 4, we get 16, which is the number of characters that was written to the file. And if you open the file, see the values that were written. Now we can that file by calling the seek method and passing in the number of bytes that we should seek up to, and then we now read from it as well. So let's see the example of that. Print f.seek, and if we run this, we get 5, which is the current position of the file, which means if we should print f.read, we should get the value of 5. Sorry, I think you should read everything. Just read one byte. What do we get? Yes, that's the current position that we are in. Now we can also seek this one out. Seek from the end of the file. by passing in a negative value and 2. 2 makes us start from the end of the file, and then -3 says that we need to start reading, so we need to get the third byte before the end of the file. And we should print this is the number representing the position where we are, and we print f.read we get the actual value that is at that position, which is D. In text files, those opened without a B in the mode string, only 6 relative to the beginning of the file are allowed. The exception being seeking to the very end with seek 0,2. The only valid offset values are those returned from the tell method or 0. Any other offset value produces undefined behavior. File objects have some additional methods such as isati and truncate, which are less frequently used. We can consult the library reference for a complete guide to file objects. Strings can easily be written to and from a file. Numbers take a bit more effort since the read method returns strings which will have to be passed to a function like int, which takes in a string like 123 and returns a numeric value like 123. So it takes the string value here and then it returns the numeric value. When you want to save more complex data types like nested lists and dictionaries, parsing and serializing by hand becomes complicated. Rather than having users constantly writing and debugging code to save complicated data types, Python allows you to use the popular data exchange format called JSON, which is short for JavaScript Object Notation. The standard model JSON can take Python data hierarchies and convert them to string representations. This process is called serializing. Reconstructing the data from the string representation is called deserializing. Between serializing and deserializing, the string representing the object may have been stored in a file or data or sent over a network connection to some distant machine. Note, the JSON format is commonly used by modern applications to allow for data exchange. Many programmers are already familiar with it, which makes it a good choice for interoperability. If you have an object X, you can view the JSON representation with a single line of code. So let's create a new example file here. Import JSON. We define our list. And now we can now print the JSON representation. To run this, 5, yeah, we get the list. Another variant of the dumps function called dump simply serializes the object to a text file. So if F is a text file object open for writing, we can do, so we can say this, open this as F. Now let's see what we get. What is wrong? Dump is missing one required positional argument. Oh, okay. So we have to pass in the list and then the file. Very good. Let's delete this. The list first. and then the file. Good. Yeah. Now, if we open up our JSON, we get to see the list. To decode the object again, if f is a binary file or text file object which has been opened for reading, we can do so. Let's say we duplicate this and comment this one out. Now this is open for reading. I'll say y equal to JSON.load f save, and now we can print y. Let's run this. Not dump, load, sorry. Yes. So this first one is the X that was printed, and the second list is Y after loading it from the file. Note: JSON file must be encoded in UTF-8. Use encoding equal UTF-8 when opening JSON file as a text file for both reading and writing. This simple serialization technique can handle lists and dictionaries, but serializing arbitrary class instances in JSON requires a bit of extra effort. The reference for the JSON module contains an explanation of this. So we're not going to go over that explanation for now, but just be aware that for classes, we may need to do a little bit more to be able to save them in JSON. The Pickle module. Contrary to JSON, Pickle is a protocol that allows the serialization of arbitrarily complex Python objects. As such, it is specific to Python and cannot be used to communicate with applications written in other languages. It is also insecure by default. The serializing Pickle data coming from an untrusted source can execute arbitrary code if the data was crafted by a skilled hacker. So take note of that. So I guess this Pickle now is an alternative to, serializing with JSON, but it has its own downside where it can be used by an attacker to run malicious code on your platform. So that's it for reading and writing files in Python. If you like the content, remember to like, subscribe, and share it. I will see you in the next one. Bye.